Part 4 of Module 2 is solving a system of equations, and I'm going to have you use a calculator to solve it. So, Objective 1, the only objective for this part is to use a calculator to solve a system of equations. Solving a system of equations means if I was giving number 1 here, I have a quadratic equation, y equals x squared plus 3x minus 5, and a linear equation, y equals x plus 3. To solve this, it means that I need to find an x value that if I were to input into both of these would give me the same y value. That is what's called the solution to a system of equations. So if I find an x value that I can input into both of these functions, it would give me the same y value. That's the whole goal of this. And I'm going to have us use our calculator to keep with the theme of just graphing and being able to evaluate a graph, a picture of a graph. So again, if I was going to do number 1 and I wanted to solve this system of equations and I was going to use my calculator to do so, I've listed out the steps right here, steps 1 through 5. If you want to hit pause to write these down, please do so. You'll need to write them down anyways. But step 1 for me, if I was going to model how to do this, I would pull out my calculator, turn it on, and then hit y equals is the first step, and then parts 1 and 2 of the first step. I'm going to put the first equation into y1, so y equals x squared plus 3x minus 5, and then scroll down to y2 and put the linear equation, the second equation, into that, x plus 3. So make sure your calculator looks exactly like mine. You may need to scroll up. If you've been using the same calculator recently, you may need to scroll up and turn this plot off if it's on. If this is highlighted like this, you need to scroll up and hit enter on that plot and turn it off. Your screen should look exactly like mine. The second step is to hit graph on the calculator. Graph. Now if your screen doesn't look like this initially, you might need to hit zoom, and then 6 is standard view. I need to hit zoom 6 to go to the standard view if it didn't look like that. So it should look like this now. You should see a parabola, a positive parabola, so it's going up, this smiley face right here, and then a linear equation or a line. You should notice two things. They intersect in 2 points. These points of intersection represent the solutions to this system of equations. So to find the points of intersection, I'm going to follow step 3 and hit second, trace, and then number 5. So second, trace, and then you can either scroll down to number 5 or just hit the number 5. It stands for intersect. And I need to bring my spider cursor. I wrote this kind of down here. Scroll close to an intersection point and hit enter 3 times. So I'm going to go to this one over here. I'm close enough to it. Get as close as you can to it. I'm going to hit enter for the first curve. Then it asks me for the second curve, so it's on the other line now. I just hit enter near it again. And then for guess, I hit enter one more time. So I hit enter 3 times. That gives me the intersection point of 2 for my x value, y, or my 5 for my y value. So I'm going to record that first. I'm going to put it in parentheses and write it as a coordinate point. 2, 5 is my first point of intersection. Now let's go back and find the other one. I'm going to have to repeat the same process. Second, trace, 5 for intersect. I'm going to scroll over to my other point of intersection now. Get it as close as possible. Hit enter 3 times. And this one is -4, -1. So I'm going to put that there. -4, -1. So I have found the 2 points of intersection. So what this means, if this is correct, and I need you to check your work as well, if I input, let's use this, 2, 5. If I input my x value of 2 into both of these linear, or both the quadratic equation right here and the linear equation here, into the x's, it should spit out 5 for both equations. So I need you to check your work for both of these. Same with -4. If I put those in for the x's, I should get -1 both times. I'll show you what that looks like then. I wrote it out here. I'm going to evaluate the first one, check my work. I've inputted 2 into my function, the quadratic function up here. So instead of x's, I have 2's. So if I did this correctly, and it does actually solve the system of equations, I should get the same answer. I should get 5 each time I do this for each equation. So if I go back to my calculator, I've already typed this in, so go ahead and get your calculator looking like mine. I hit enter. It does indeed, this input of 2 gives me 5 for the quadratic term. If I do this for the linear function now, I will do y equals 2 plus 3. And that also indeed gives me 5. So I know that this coordinate point system solves this system of equations. If I want to check -4, -1, I can go back to my quadratic function and let me scroll over, and instead of 2 I can put -4, and then instead of 2 here I can also put -4, and see if that gives me -1, and it does, so that works as well. And if I use that in my linear function, -4 plus 3, that also indeed gives me -1. So I need you to be able to show me that you can check your work. I only did this over here, but I could actually write this does indeed equal 5, and then y equals parenthesis 2 plus 3 to show my work. And this also indeed equals 5. So I know that this one works, and you can show me that the other one works, -4, -1 as well. If they both check out, then you have solved this system of equations successfully, and there are 2 coordinate points that solve this system of equation. Go ahead and try 2, 3, 4 all the way through the last one, number 10.